Okay, so get this, right? We're going to try to, like, get inside the mind of a large language model,
Oh, wow.
an LLM.
Okay, yeah.
I know, it sounds kind of crazy, right? Like, how can something think if it doesn't even have a brain?
Yeah.
But trust me, these LLMs, they're doing some pretty intense processing with information, and it's really, really interesting stuff.
It is.
Like, imagine you ask an LLM, Michael Jordan plays the sport of blank, and it instantly tells you basketball.
Right.
It seems simple, but how does it know that? How does it make that connection?
Right.
That's what we're going to look at today.
Yeah, that's really fascinating how that seemingly basic task, it hides all these like complex calculations and connections that are happening in the background.
Right.
And it all starts with this this piece of technology called the transformer.
The transformer. Okay. That sounds powerful. That sounds impressive.
Yeah.
Is that where all the thinking is happening?
Yeah, you could say that. So the transformer is the like engine of a large language model.
Yeah.
And it's got these two really important components. It's got attention and multi-layer perceptrons.
Okay. Attention. That sounds a little familiar. Isn't attention how LLMs figure out, like, the context of different words in a sentence? Like, how a pronoun refers to, something earlier in the sentence? Or
Yeah, I got it. It's like a spotlight that shines on the relationships between different words.
Yeah.
And it helps the LLM understand the overall meaning of, like, what's being said.
Okay. I got it. So what about those multi-layer perceptrons?
Yeah.
Is that what they're called? MLP?
MLPs.
Okay. Yeah, so they're the part that really stores those Michael Jordan basketball facts.
Okay, so MLPs. I'm already starting to get a little lost in all this jargon.
Yeah.
What are MLPs actually doing to store information?
So imagine them as intricate networks within the transformer.
Okay.
And they're doing a whole series of mathematical operations, almost like forming pathways in a network.
And these operations are things like linear transformations, and there's things called nonlinear activations, and these operations help the MLPs learn complex relationships between different concepts.
Okay, so we have these MLPs. They're making connections between different concepts.
Right.
But how does that actually, like, translate to knowing that Michael Jordan plays basketball? Like, how does that work?
Yeah, so let's use that example, that Michael Jordan example, to break it down a little bit.
Okay.
So imagine a vast, multidimensional space inside the large language model.
Okay.
Where specific directions represent different concepts. So you would have, a direction for first name Michael, a direction for last name Jordan,
right,
and of course a direction for basketball.
So it's like a giant map of all these different ideas.
Exactly.
Okay.
And each direction is a different concept.
I'm starting to see it now.
Yeah.
Okay.
Now think of vectors as arrows that point in these different directions.
Okay.
And when a vector aligns strongly with a specific direction, it means it's encoding that concept.
Okay.
So a vector for Michael Jordan would point very strongly towards first name Michael and last name Jordan.
So the direction of the vector tells us what concept it represents.
Yes.
Oh, that's cool.
So it's like a code for meaning inside this huge space.
I like it.
Yeah, and the MLPs, through all of their complex calculations, can recognize this Michael Jordan vector
Okay.
when it's in the input. And then they activate a neuron that adds the direction basketball to the output.
Okay.
And that links those two concepts together.
Wow. Okay, so just by seeing Michael Jordan, the MLPs trigger this whole chain reaction as like a domino effect, that leads to basketball.
Yeah.
It's so cool.
But here's where it gets really mind-boggling. Okay.
Okay.
So it turns out that those neurons in the MLPs, they might not just be representing one concept at a time.
What?
They could be encoding multiple concepts at the same time.
Hold on. Multiple concepts in a single neuron. How does that even work? Wouldn't that get super confusing?
It's a phenomenon called superposition.
Superposition.
Yeah.
Okay.
Think of it like a single neuron wearing multiple hats.
Okay.
This neuron could be helping to represent Michael Jordan, basketball, and a bunch of other concepts all at the same time.
Wow.
It's part of what makes large language models so efficient at storing huge amounts of information.
Okay, so we have these superpowered neurons are juggling all these multiple concepts at the same time. It's pretty impressive, I gotta say.
It is.
But how do we as humans, like, how do we even begin to make sense of what's happening inside these crazy complex models?
Yeah.
It feels like trying to understand the thoughts of like an alien species or something.
It is a challenge.
Yeah.
But we're not totally in the dark.
Okay.
That's where tools like Google Cloud's Vertex AI come in.
Okay.
So it's a platform with a ton of resources for building and deploying.
Mm-hmm.
But most importantly, for understanding these complex machine learning models, including LLMs.
So Vertex AI is like a window into this black box of an LLM.
Yeah.
Tell me more. What can it actually do?
So first of all, it gives you access to all these different pre-built LLMs.
Okay.
And it lets you build your own custom ones.
Okay, cool.
But what's really exciting for us today is it focuses on model explainability.
Yeah, because trying to decipher those MLPs and all their math on our own, I think that would take a really long time.
Yeah, it would be a very long and confusing road.
Yeah.
So explainability, I like that.
Yeah, I like the sound of that.
So what kind of tools does Vertex AI have to make these models easier to understand?
Yeah, what can it do?
So one of the most powerful tools is the metadata API.
Yeah?
So think of it as like a detective's toolkit for your LLM.
Okay.
And it tracks every single step of the model's creation, starting with the data sets it was trained on
Okay.
to like the specific versions and settings that were used.
So we can trace the LLM's entire lineage.
Yeah.
It's like a family tree, but for AI. That's pretty cool.
Exactly.
That would be super helpful for figuring out where an LLM's knowledge comes from.
Yes.
And even like its biases.
Yeah, exactly.
It's amazing.
But it gets even better. The metadata API can also log what's happening inside the MLPs while the model is training.
Really?
So we can actually see the outputs and the activations of those neurons.
Oh, wow.
As the model learns.
But we can see those neurons firing in real time.
Yes.
That's incredible.
Yeah. So this is super valuable for, researchers that are trying to figure out how these MLPs are actually representing knowledge and making these connections.
So it's like those neurons are finally telling us their secrets.
Yeah.
It's like we're peeking behind the curtain and seeing how the wizard actually works.
Yeah, exactly.
That's so cool.
So with all this insight from Vertex AI, are we getting closer to understanding how these LLMs think?
I mean, I don't know about you, but my mind is officially blown. We've gone from transformers to MLPs to neurons firing in real time. It's been quite a journey.
It has, and we're not done yet. So in the next part of our deep dive, we'll explore how LLMs go beyond just facts.
Okay.
And actually deal with things like opinions and beliefs.
Ooh, that's interesting.
So stay tuned for that.
I will. Okay, so I'm still thinking about that whole superposition thing.
Yeah.
Neurons juggling multiple concepts at once.
Right.
It's incredible, really.
It is.
But it makes me wonder, if LLMs are so good at storing facts, what about, like, opinions?
Right.
How do they handle, those fuzzy ideas, the subjective stuff?
Yeah, that's a great question.
Yeah.
It takes us into this whole other dimension of, like, how LLMs process information.
Okay.
So you see, LLMs, they're trained on massive amounts of text data, right?
Right.
And all that data includes all sorts of human expression. You've got news articles, books, social media posts, you name it.
So they're getting the full spectrum of human opinion, all different perspectives.
It is.
That's a lot to process.
Yeah, it is a lot to digest.
Yeah.
And within all that data, there are countless opinions, viewpoints, beliefs expressed on pretty much every topic imaginable.
Okay.
But LLMs, they don't form, like, their own opinions the way we do.
They can't think for themselves, yeah.
Right, exactly.
Okay.
Instead, they develop this thing. It's what we call a statistical representation of the opinions that they've encountered in the data.
A statistical representation? What does that even mean?
So it's like they're mapping the landscape of human opinions based on all the patterns that they see in the data.
Got it.
Yeah.
So they're learning to associate certain words and phrases and ideas with certain opinions.
Right.
Okay, so when we ask an LLM a question, it's not just pulling up facts. It's also using this map, this giant map of opinions.
Exactly.
Okay.
So, for example, if you ask an LLM, what's the best way to solve traffic congestion?
Yeah.
It would tap into its knowledge of, like, all the different arguments, all the different perspectives that it's seen.
Okay.
And then it'll generate a response that reflects those patterns.
So they're more than just fact machines.
Right.
They're also capturing something about the way humans think and argue.
Exactly.
But that kind of makes me wonder what happens if the data that they're trained on is biased?
Yeah.
Or skewed in a certain direction.
Right.
Will the LLM just spit back those same biases?
Yeah. So that is one of the big challenges with LLMs.
Okay.
And it's definitely something that researchers are really working on.
Okay.
Because, since these models learn from the data they're given, they can reflect the biases
Makes sense.
that are in that data.
It's like that saying, garbage in, garbage out.
Exactly.
Right.
Yeah.
So if we give LLMs biased information, we're going to get biased results.
Yeah, that's why it's super important to be really careful about the data that's used to train these models.
Right.
And there's a lot of work being done on developing techniques to detect and mitigate those biases.
That makes sense. So it sounds like it's this constant balancing act to make sure these LLMs are neutral and objective.
Yeah, exactly.
Is there any way to stop them from having opinions at all?
Right.
Can we train them to stick to the facts?
That's a really interesting thought.
Yeah.
But it's trickier than you might think.
Okay.
LLMs, they're designed to generate human-like text.
Right.
And human language.
Yeah.
It's full of nuance.
Yeah.
And subjectivity.
Right. Even factual statements can be loaded with opinions.
Exactly.
Okay, so trying to completely separate facts from opinions is kind of impossible.
Yeah, it's all intertwined in the way that we communicate.
It's all connected.
Yeah, and so it's important to remember that that LLMs are tools.
Right.
And like any tool, they can be used in a lot of different ways. So it's really up to us to use them responsibly and to be aware of their limitations.
Okay, that's a good point. It's not just about the technology itself.
Yeah.
It's about how we choose to use it.
Exactly.
We need to approach LLMs with a healthy dose of critical thinking, just like we do with any source of information.
Exactly.
Which leads to another question.
Right.
Can LLMs actually reason in a way that's similar to human thought?
Yeah.
I mean, we've seen they can store facts.
Right.
Handle opinions.
Yeah.
Can they go a step further?
Yeah.
Solve problems or come up with new ideas?
So LLMs have actually shown some pretty impressive abilities in tasks that need logical reasoning and problem solving.
Okay.
They can solve logic puzzles.
Really?
They can generate creative solutions to hypothetical scenarios.
Wow.
And they can even write code in different programming languages.
Hold on, they can write code?
Yeah.
That's amazing.
It is remarkable. So one theory is that they use their massive knowledge base and their ability to, process language to almost simulate an internal dialogue.
Why?
Or like a chain of thought.
Like a conversation with themselves.
Exactly.
It's so cool.
Yeah, it's as if the LLM is generating all these different hypotheses.
Okay.
Evaluating each one.
Right.
Discarding the ones that don't work and refining the ones that, show promise.
Wow. So they're using language as a tool for thinking.
Exactly. Just like humans do.
That's a really cool concept.
It is.
It's also a little scary.
Yeah, it can be.
Yeah.
But what's even more amazing is that this kind of reasoning, it doesn't require specific programming.
Right.
It seems to just emerge naturally.
Wow.
From the LLM's training.
So from seeing all that data.
Exactly.
Okay, it's they're developing these reasoning abilities on their own.
Yeah.
That's, I don't know, it's kind of fascinating.
It is.
It's also a little unsettling, isn't it?
It definitely raises some really profound questions about the nature of intelligence and the potential of artificial intelligence.
Yeah, it definitely makes you think.
Yeah.
I think we've given our listeners a lot to think about today.
I think so.
We've gone from facts to opinions to the ability to reason.
Yeah.
It's pretty clear LLMs are way more than just sophisticated parrots.
Absolutely. And in the final part of our deep dive, take a look at some of the cutting-edge research and tools that are helping us push the boundaries of what we know about LLMs and how we can shape their future.
Okay, sounds good.
So stay tuned for that.
Okay, so we've seen how LLMs store facts and handle opinions and even reason like us. It's pretty amazing stuff. But where do we go from here?
Well, you're absolutely right. That's what makes this field so exciting. There's tons of research and development going on right now, just pushing the boundaries of, what we even know about these LLMs, and then also how we can use all their potential.
So what's on the horizon? What are the big questions that researchers are really trying to tackle right now?
Well, one of the biggest ones is interpretability.
Okay.
Remember those MLPs and how they speak this mathematical language?
Yeah.
Well, researchers are trying to figure out how to crack the code.
Okay.
So translate those calculations into something that we can understand.
It's like creating a Rosetta Stone for LLMs.
Yeah, exactly.
Imagine being able to look inside and see how they're connecting ideas and making decisions and, even forming those chains of thought we talked about.
Yeah, and we're actually making progress.
Oh, that's cool.
One approach is using visualizations to represent like the inner workings of LLMs. So think of it like creating maps of their mind.
Maps of an LLM's mind. Okay, that's wild. What can we even learn from those maps?
Oh, all sorts of things. We could find that LLMs associate certain words with, like positive or negative emotions.
Oh, interesting.
Or that they're grouping these totally unrelated concepts together
Okay.
in ways that we never would have thought of.
So we can actually see their biases.
Yeah, and potential errors in their reasoning. And it can even help us improve how well they work.
It's like we're peeling back the layers, getting a glimpse into how their logic actually works.
Yeah.
It's pretty fascinating.
It is.
But also kind of scary, right? The more we understand these LLMs, it seems like the more complex they get.
Yeah, that's the beauty of it.
Yeah.
Every discovery leads to more questions. And it's not just visualizations.
Okay.
Researchers are also using probing tasks.
Probing tasks? What are those?
So they're like challenges that test the LLM's abilities to do certain cognitive functions.
So things like understanding cause and effect.
Exactly. Or recognizing logical fallacies. Or even coming up with metaphors.
So we're giving them mental gymnastics to flex their cognitive muscles. I like
Yeah, exactly.
Yeah, that's a good analogy.
And then we analyze how they perform on these tasks.
Okay.
And then we can see, their strengths and weaknesses.
Okay, so we see where they excel, where they struggle.
Yeah, exactly. And where they might need more training.
Okay, so it's like we're constantly challenging them to level up their skills.
Yeah. Got it.
But all this research, it's not just for understanding, right?
Right.
There's got to be a bigger picture here.
Yeah, the goal is to develop these AI systems that are, more explainable and more trustworthy.
Okay, so explainable, trustworthy AI. Now, those are some words I like to hear. It makes me think of all those, sci-fi movies where AI goes rogue.
Right, yeah.
And it starts making its own decisions.
Yeah, I know what you mean.
Often with disastrous results.
But in reality, AI is a tool, right?
Right.
Like any tool, it can be used for good or for bad.
So how do we make these LLMs more transparent? How do we get them to, show their work?
That's a great question. One way is to get LLMs to generate these things called rationales along with their answers.
Rationales, what are those?
So it's like getting them to explain how they reached a conclusion.
So it's a step-by-step breakdown of how they got to a certain answer.
Yeah.
That would be super helpful in situations where you need to really trust the AI, right?
Yeah. For example, imagine a doctor using an AI assistant to help diagnose a patient.
Yeah.
The AI would not only give a diagnosis,
right,
but it would also explain the reasons why.
Okay.
So the doctor can make a more informed decision.
Wow, that's a total game changer.
Yeah.
It's like, it's not replacing the doctor. Yeah. It's just giving them more info to make a better decision.
Exactly. It's all about collaboration between humans and machines.
It's amazing to think about all the potential here.
It really is.
Like in healthcare and finance and education. Yeah. Everywhere.
Everywhere.
It's an exciting time to be alive, wouldn't you say?
I definitely think so.
We've come a long way in this deep dive. From transformers and MLPs to, these big philosophical questions about consciousness and what intelligence even means.
It has been a journey. Mm-hmm. And it's important to remember that this is really just the beginning.
Yeah.
The field of AI is constantly evolving. And there are still so many things to learn.
Okay, so for all you listeners out there, the main thing to remember is stay curious.
Yeah.
Keep asking questions. Mm-hmm. Never stop exploring.
Yeah, who knows what incredible discoveries are waiting for us.
The world of AI is waiting.
Exactly. Until next time, keep those minds engaged and those imaginations going.
Absolutely.
The world of AI is waiting to be explored.